Welcome once again, guys, to the third session of the Cairo 3 Bootcamp. We're happy to have you here again, and we hope that you enjoyed the first two sessions that we had. And Cyndie will be your tutor for today. She'll be taking you on building on Starknet. She'll be taking you Cairo programs versus Starknet contracts, events, functions in Starknet, everything you need to know to get started writing Starknet contract. And she's going to be taking you through how to write a storage contract and so much more. For people that I know, a lot of persons have been submitting their assignment so far. We had a number of people submitted their first assignment, but the energy dropped a bit for the second assignment, and I feel it's because of some struggles solving the Starknet challenge. But we said if you have questions or blockers, always make sure you post them on the Starknet Africa Telegram channel. And one thing you also need to know is that there's going to be a spoke NFT that's going to be sent to all active participants for the bootcamp at the end of the bootcamp. Right, and that will be for the active participant. Active participant means you're attending classes and you're doing your assignment. So make sure you do your assignment, and it's going to be like a certificate of participation in one of the Starknet bootcamp, right? And I'm sure you don't want to miss that. And also, I think I will just have the remaining talk after the class, so we can have a lot time to for Cyndie, right, to take the class. So hi Cyndie, I think you can take over now.
Okay, hi everyone. Hi again. My name is Cyndie Kamau. Thank you all guys for joining. So I'll be taking you guys through several concepts in smart contracts in Starknet today. And yeah, without further ado, let's start. First of all, thumbs up if everyone can hear me well. Yeah, it would really help me so that nice. Okay, so let me just quickly share my screen. It'll give you guys like an overview. Okay, great. Okay, so just let me just okay. Okay, can you guys see my screen well? Let me see if we can. Okay, can you guys see my screen well? All right. Let me go back and okay. Yeah. So just to give you guys what we'll be doing, it's first of all, let me quickly introduce myself. First of all, welcome guys to the Cairo Bootcamp, the third week of the Cairo Bootcamp, where we're teaching you guys development on Starknet. So my name is Cyndie Kamau. I'm from Kenya, and I'm a blockchain developer. Mostly, I call my tech stack mostly is Rust and Cairo also, but mostly it's Rust. And also, I'm a developer advocate, so I love teaching a lot of blockchain concepts and also just programming in general. So this is my Twitter handle. You can this is like my avatar. As you can see, I love wearing muffins a lot. So yes, yeah. Let's continue. So in today's agenda, first of all, before we even handle smart contracts, there's a very important topic and section in development in Cairo that I really wanted to go through, which is traits and generics, because this is really used in smart contracts. And I thought it's nice to just give a refresher and also like take you guys through how traits and generics works, because you're going to see a lot of the syntax for traits and generics when we start discussing about smart contracts, right? So that's it. Also, last week, Olwasid talked to you guys Cairo programming language. Okay, slideshow, okay. Okay, that is okay, right? Sorry, I have to put this small floating icon here so that I can see. Okay, so, but in case you guys want me to like remove it, you can tell me if it's like what it's just it helps me to monitor if there's any questions and all. So yeah, like I was saying, we first go through traits and generics, and also we're going to go through the differences between Cairo and Starknet smart contracts, since there's a difference. Cairo, which last week people went, Olu taught us how to essentially just an introduction to Cairo and all. But in case anyone did not meet, anyone was not in the meeting last week's call, we can share like a recording so that you can go and check it out. Yeah, so after that, we're also going to like go through the anatomy of a smart contract, like what is like the blueprint, or what is, let's say, the backbone of a smart contract in Starknet. What does it need to have, right? Also, we're going to go through some specific things like storage, functions, and events in smart contract. And lastly, we are also going to go through Syscalls in Starknet, because it's also an important topic, right? So also, before I continue, let me just escape for a while so that I can show you guys other things. For as we continue, I'll be doing some bit of coding sessions, especially with like traits and generics, and also I have some sample smart contracts. Example, this is like a simple storage smart contract, which we're going to use when we're going to like decrust it when we start learning about the anatomy of a smart contract. And then when we go through the more advanced topics such as the function events and all, we are going to use this name registry smart contract. So in case you guys want to follow through, because these two smart contracts are like they're readily available. So let me just quickly go to the Cairo book. And I'll share the link here, so that guys can follow through. So it's not just listening, you're also like decrusting also on your end, so that we have like a bit more responsive, so you can yeah, your 2 hours here, you can come out learning something. So let me just share the link. Okay, so when we come to anatomy of a smart contract, you're going to find the smart contract here. So let me just quickly share this link here, just as house rules, so that we can have a very what's it called, flex, like a very smooth experience, right? So we have that. And then also when we now start talking about other advanced things for smart contracts, we are going to go and decrust this smart contract. So you can copy it, you can do what, but also just we'll also take you guys how to like create like a Starknet or rather a Cairo file, so you can paste it there and then you can just play around with it. Yes. Okay. All right. So without further ado, that's what I wanted to say in the beginning. So let's just start. Okay, so our first section is traits and generics in Cairo. So if someone is just to accommodate anyone who's like starting, this is the first time attending the bootcamp. So Starknet is a layer 2 protocol in the blockchain ecosystem. So the main concept of Starknet is in technical terminology, we call it like a validity rollup. So Starknet essentially helps process transactions and send like a proof to Ethereum. So Ethereum is just verifies it and stores it on chain. So the whole concept of like layer 2s, it's just to help increase transactions which are being processed, and then to help Ethereum, right? Because Ethereum on its own is a bit slow. Just to increase something we call TPS, transaction per second, right? So that is Starknet. So the whole concept of Starknet as a layer 2 is it helps in mostly proofs. So something we call like validity proofs. Example, it's just showing proof that whatever transactions it has processed, if you want to go and verify, just to ensure that it's sort of like showing a proof that all the transactions were processed correctly, right? So to give you guys a quick overview of how the Starknet architecture looks like, so we first have something we call the mempool, and a mempool is where all the transactions will be stored, like a temporary storage for transactions, right? And by transactions, I don't just mean financial transactions. Let's say X sent money to Y, that's still a transaction, but anything that is affecting the state of the blockchain, we call it like a transaction, right? So once you go to the mempool, we have something we call as the Starknet sequencer. So the Starknet sequencer, its work is it makes like the first verification of these transactions. So this sequencer, the reason why I'm mentioning the sequencer is because you'll see its importance when we delve into the differences between Cairo and Starknet smart contracts, right? So this smart contract, the whole work for it in a smart contract is you get to the sequencer, sorry, you get to verify the transactions. If a transaction is and produce blocks for Starknet, right? So if a transaction is invalid, it will still be given a label, right, for invalid. If a transaction is valid, it's going to be given a label accepted on L2. So it continues like that. So once the sequencer starts to produce blocks for Starknet, these transactions, which are the blocks, they go to something we call the prover. So the prover will generate proofs of these transactions which are bundled up, right? So if you have transactions and then it has gone through the sequencer successfully, whether it was an invalid transaction or not, it will go through the prover. The prover will create proofs for these transactions, and then the proofs are going to go to a set of smart contracts in Ethereum layer 1, which you call the verifier. So the verifier, their work is just to verify the proofs that Starknet has produced for these transactions. Once they test and they realize all the transactions are okay, the verifier will now they will sort of approve this transaction, so the transactions will be the state of Ethereum will be like updated, right? So that's just a quick introduction to anyone who was not when we started out or the bootcamp, anyone who was not available. So just to see how Starknet works essentially, right? So Cairo is a programming language which was designed by the Starknet team. And why they designed their own language is because since Starknet is bullish on proofs and all, so they had to create some sort of programming language which, when you write any program, it sort of creates its own proof when you run the program. So any program which you build in Cairo, we call them essentially provable programs, right? So that is Cairo. Cairo is the programming language which was designed by Starknet. It's a general purpose language. What I mean general purpose is you can build any language. Let's say it's kind of like how you can use Rust. Rust is a general purpose language, right? So the same with Cairo. It's only that with Cairo, it was designed by the Starknet team. So here we're going to talk about traits and generics in Cairo. Yes. So I have an analogy of what traits and generics essentially are, but I do believe the best thing would be, let's have our first live coding session. So guys, you can be able to internalize, why do we need traits and generics, right? So, okay, let me just clear. Okay, so I hope guys can see my screen. So in case you don't see my screen, my terminal, you can tell me. Otherwise, I'll continue. So when I want to talk about traits and generics, the example I'll be using in Rust, that Rust is easier for me to explain the concept of traits and generics. And then we're going to connect with the syntactical differences, the difference between the syntax for Rust and Cairo, right? So, and also for development environment, since we set up the development environment last week, so if you set up for Starknet, obviously you have Rust. Yeah, I hear like so I don't know if it's a question. Let me go back. Okay, was it like in case you have a question, you can just also unmute your mic because I'm not like seeing. Let me just a second, guys. Okay, why do we need Cairo instead of Rust? Like the way I explained is with Cairo, since Cairo is essentially, it's like the cousin of Rust, if I can call it, right? So the syntax is almost similar. The only difference is a bit here and there in terms of syntactics. Okay, I expand my screen. I will, right? So the only difference between Cairo and smart contract, and Rust, sorry, is that Cairo is designed when you build a Cairo program, it's like you're generating proof for it, as opposed to Rust. When you compile like a Rust program, it will just run, right? But the difference now with Cairo, when you run like a Cairo program, the way the virtual machine is designed for Cairo, it's designed to generate proof for the program that you're building. Yeah, so that's the difference. So with Cairo, you build something we call provable programs, but with Rust, it's just a general program. But otherwise, in terms of syntax and all these other things, they are very similar with only different differences. Like example, with Rust, you'll find like the default type for when you're like writing a value or a variable, the default type is like I32, right? But for Cairo, you'll find like the default is a field element, felt 252. So those are some of the two small differences between like Cairo and Rust, but otherwise it looks the same. They're just like cousins, or step brothers, if we can call them. Okay, so yeah, I need to let me just zoom in. Okay, I hope, Kevin, you can like see my terminal, because I'm going to my terminal to show anyone who does not know how to like create like a Rust program, how we do, right? So okay, so here it's just my directory. So I will just create like a new program. Let me just call it like let me call it what? Okay, so what's the difference between Rust and Cairo in this place? For here, you can see I have this package manager called Cargo, right? If I was to do the same with Cairo, I could do it, especially when like writing a general purpose program, right? I will use something we call Scab. So Scab and Cargo work the same in different aspects, right? So Scab is specifically for Starknet, just the same as how Cargo is specifically for Rust, right? So Scab new example 2. So the only difference is you're going to choose between something we call Starknet Foundry, it's a tooling in Starknet, which you'll be able to see it in a very extensive way next week. So we have something we call Starknet Foundry. This is what we use when you're like writing smart contracts to help you interact with your smart contract and also deploy your smart contract, right? But since I'm just doing like a simple Cairo project, I'll just go with the Cairo test. So remember, Starknet Foundry mostly for smart contracts, but if you're writing like a general purpose Cairo program, we use Cairo test, right? So that's the same, it's the same thing, okay? So let me just, okay, so far I hope everyone is like following through with what I'm where I am right now. I hope you guys can see my terminal. Let me just go back to the screen and ensure if there's anything I'm missing. Okay, yes, thank you. So in case anyone is not seeing my screen properly, you can just say, okay. Yes, you're still at my gate. Oh. Still at my gate. Can everyone see my terminal? I mean, not my terminal, my VS Code. Okay, yes, okay. Okay, so the reason why I want you guys, before I even show you like just to give you guys why do we need traits and generics and what are traits and generics, right? So that before we even go to the analogy, so you at least you see live why we need it, right? So traits and generics. Now let's say I have an array, right? And let's say we just have an array. An array is like let's say we have an array, right? So, and I want to go through all the digits or all the fields in my array and add them, right? So what will I do? Let's say I have, let me just come here, let me remove this. Yes, so let's say I have like a let array 1 equals 1, 2, 3, 4, 5. An array is just like a collection, if I can call it a collection of values which need to have of the same type. Okay, so this is like an sorry, this is like an array, right? So let's say I have array 1. As you can see, like I was saying, when you check out an array, you find like the default for Rust is like I32, right? So if it is Cairo, the default will be like felt 252. So let's continue that. Array 2, 6, 7, 8, 9, 10. So what will I do if I want to like calculate the sum of all these digits here? So what I will do is I will just have to first of all initialize the index of this array of mine, right? So let sum of my first array, right? Let sum array equals array 1, 0. So that's like I've initialized the index of my array, right? Then after that, I have to do something like we call iteration. I will have to jump through all these digits inside my array and then count them, right? So I'll have to jump through 1, 2, 3, 4, 5, like that. So to do that, I'll have to say for I in So what I'm just saying is for every digit in the entire length of my array, what do I want to do? I want to add, like add this, right? So I will just say sum array 1. Okay, so I'm getting an error. Let me see. So my error is saying cannot mutate immutable variable sum array 1. So this will reinforce something which we learned last week. All values, whether it is in Rust or it is in Cairo, all values are immutable by nature. So by immutable, you cannot change, right? So if I want to change, let's go back to the error. It's saying my variable sum array 1 is immutable. Like you can see, I'm trying to add everything here because I've initialized it to 0, right? So it's for now the sum is like 0. Okay, so I want to add all these details and then continue updating here because we've started it with 0, right? So I want to add and continue iterating upon it, but because it is immutable, it's throwing an error. So to so that I have to put like the mute keyword. It's also the similar to Cairo. You have to also put mute, right? So let me just see what I'm doing wrong.
You are adding an integer to an array, so maybe read an index of that array 1.
Oh yes. Okay, sorry, I had forgotten. Yes, that's it. Yes. So yeah. So like Dalmas, I said thank you, Dalmas. So I was adding like an integer, like I was supposed to add like the index, right, instead of a whole array. So I had to put this I here, right? So that's it. Thanks. So, yeah. So let's print it and then we see. Okay, so let me just, yeah. So okay, so this is so to run this, we are going to, so if I was doing the same in Cairo, I would have written scab Cairo run. Okay, so these are some of the subtle differences between Rust and Cairo. Otherwise, the syntax is still the same. Okay, so you can see the sum of our first array is 15, right? But now the issue is, if I want to do the same with array 2, essentially I have to repeat this code again, right? Because I have to, let's do it so you guys can see. So yes. Okay. Okay, so if we run this in the terminal again, you find, yes, the sum is 15 and 40. But now imagine you're writing like a program and you have like 1,000 arrays. It will be very, it's not like good practice. It will be very redundant to continue writing all this code, right? So what is the very basic thing someone would think of doing? What we would think of doing is writing a function, which will like handle specifically adding arrays, right? So that would be the first step someone would think of doing, right? Because now it means if we have like 1,000 arrays, we have to do this repeatedly. And that is not like it's not a very productive way of like writing code, right? So sorry. So let's write a quick sum of array. Now inside our function, you're going to put like the array as a parameter. Okay, since you're going to essentially you're going to be calling this sum of array function, and then you write like the array that you want, right? So right. And then we give it like, let's say we put the type, right? So something I want to talk about. Okay, let me finish and then I'll tell you guys something else. So inside the sum of our array, first of all, we first need to initialize. We need to initialize like the first count for our array here, right? So we're going to like just like how we did here, we're going to do the same. So also, after we do that, we now iterate over it, right? So for and then we call okay. Let me see. Just a second. Okay.
Array to int, array plus int.
I'm sorry. Okay. Let me just do, okay, binary assignment operation.
Sumnum is an array. And you are adding an integer
Oh.
to it.
Oh, right. Sorry. Oh my God, sorry. I confused. It was supposed to be equals. Yeah, I've seen where I made a mistake. Yes, I had forgotten to like initialize it here. Okay, so this is the function, right? So essentially,
Sorry,
once we now have,
hi
sorry,
Cindy.
yes,
Can I ask a question before you move ahead? I'm quite
okay,
on that part of the implementation in the main. I think it's the same thing you're quite doing in this function, some of
yes,
it. So
yes.
my question basically is if you are to assign a value to say for example the first one, which is array one, right? I see you
Mm-hmm.
assign a value to some array one, and you were specific at choosing the index 0, which is 1, right? So you're saying some array
Yes.
1. So if that be the case and it goes through the list of array 1, shouldn't the total be 16? um how is it 15 then? I'm just quite confused because I've been trying to um, read through it. Maybe I'm not seeing it right. What's that thing that is making it still return 15 at the end of the day?
Okay, so you're talking about this one.
Maybe you could tell me why, how is it being done like that? Because I'm more of I'm not really used to the syntax, so you could probably explain yeah, the one dash dash num dot length. I don't know how is it making it 15 at the end of the day and not 16. I don't know if I'm making sense.
Yes, you're making sense. Although, okay, let's do like a manual because I don't understand where you're getting the 60. Okay, so you added, let's say, essentially you added this to 15 and then you added this one, right? So that's why you're getting like 16. So this is not like a field. Okay, so that you don't get confused, I can change something. Let's change it to like number 7 so that it stops being confusing. So, but when I write this one here, numlen, I don't necessarily mean like the value here. It's more like of like the index. So this is like a way we do in Rust to sort of iterate. So that's why you have these 2 dots over here, right? So it's like I'm telling the compiler from I initialized my index for my array to 0, right? So it's like I'm telling the what's it called? I'm telling the compiler, right? So I want to iterate over all these digits in my array. That's why I have it here, right? So I want to iterate over it until the end, and then I want to pick, after in every step, I pick the number, and then I do whatever I want to do to it. That's why you see I'm having this here. Yeah. So it's how we write it in. It's like a syntax, how we write syntax for us, just to tell the compiler, I want to iterate, I want to jump over all these values which are in my array. And then if I make a step here, I will do whatever I write in here I want to do, right? So when you see me writing this, it's like I will first start with 7. So and then when I make to the next step, I will add 7 plus 2, and then I will get 9. I record. So when I get 9, I go to the next step, which is 3. I do 9 plus 3, which will be 12. I record. And then when I go to 12, I come to the next step, which will be 4. So it'll be 12 plus 4, 16. I record 16 here. So that's what we are doing until we get to the very last digit in the array. And then we're done with
So,
the iteration. Yes.
so you're saying that the norm, the index 0 of the norm array, right? You're literally
Yes.
saying it 0, it is 0 at index 0. So if
Yes.
um with the with my knowledge on Web 2, right? Normally you assign array 1 to be 5 um size, right? 5 digits in size, right? So, but if you're going to be counting it by indexes, it's going to be this number 7 will be index 0, index 1, for
Yes, yes.
index 2, index 3, and index 4. So at the end of the day, it's just 4 index. So if you're assigning num at index 0 to some num, that is already making it 1. Okay, you have 7 here. That's making it 7, right? So going from the top of the list again, it is assuming
Mm-hmm.
it is summing up or adding 7 to the 7 that some num has already, which
Mm-hmm.
is 14 already. So it is literally not starting from 7. If is I'm still pretty much confused on how what is making it except the initialization here, the assigning of this value at line 5, it's 0 and not the very first digit in that array.
How will I explain? Okay, let's do this.
Can I come in?
Yeah,
Okay,
yes,
fine.
please.
Yeah.
Okay, good evening, everyone. So the thing is, the normal loop that you know is you assign some 0 to be equals to 0. Then
Exactly.
you start your looping. So this, if you check the loop now, the loop
Yeah.
is starting from index 1, not 0. So if you had assigned some num to be equals to 0, then you
Yeah.
start your loop from 0, which is this first index here. But if you are to loop now, then you are doing 0, which is this sum num, plus the first index, which is 7. So at the first looping, your sum array 1 is 7. Do you
Okay.
follow
So
up to this
Yes.
point?
that means at the
Yes.
point at
But
which the loop is going, it is starting from index 1 and not 0 anymore.
yes, from index 1. That's why they are assigning the first element in the array to be equals to some num here. Look at on that line 5. So they are
Okay.
skipping that process of starting the looping from, because 0 plus the first index will give you the first index, the first element in the
Okay.
array. So automatically they're just assigning some num to be the first element in that array. Then they are skipping that, starting their loop from 1.
1. Okay. That's why this 7 is in 1 dash
Yes,
dash.
that's why it will still work, because you have
Okay.
assigned the first. Yeah.
Okay. Thanks, Chief. Thanks. I get it now. All right, Cyndie. Thanks. Okay, go on.
Okay, thank you for the for expounding on that, right? So like he said, right? So in case anyone has any other question, we can continue. Otherwise, yeah, I think I can continue, right? But thank you very much, Chief, for that. Okay, so where was I? Okay, so we have this function, right? So we've written like the sum of an array and all these things. So when we now come back here, let's remove like, let me just comment out all of this. Okay, when I come back now, I have my array 1 and I have my array 2, right? So if I want to print out, I can always come back and I call the function, right? Which is sum of array, and then I borrow like okay. So okay, let me also, so let's go to our terminal and then we see, right? Okay, just to ensure everyone is seeing, let me run that again. Yes. So as you can see, we are able to do it, right? So this one will be able to abstract away this whole thing of like writing recursively functions which look similar. Okay, so now let's add another array, another scenario, right? So let array 3. But now in this case, instead of it being I32, let's put it into like, let's say I64, and then we'll give it like 5 values still, or we can even give it 6 values. Okay, so let me say it's 2, 4, 6, 8, 10. Are they 1, 2, 3, 4, 5? Then like 6. Have I put 6? Okay, 8. Yes. So I now have 3 arrays. One is in the type I32 and another one is in the type I64, integer 64, the 64-bit, right? So we can let's copy this and then we try to like implement it and then we see the error we're going to get, right? So oh okay, so as you can see, let's see which type of error we're getting. So we are getting like a mismatched types error, right? Because it expected like a reference for I32. By reference, it means we are borrowing. So this is something else, which is a very important concept in both Rust and Cairo. It's called a ownership, right? So this is something we're calling borrowing. I'll also expand on it as we continue with smart contracts because of time, right? So it was expecting, based on the conditions we've put in our function, it is expecting an I32, right? But we've given it like an I64. So imagine now you're having different types of arrays or different types of data structures with different sorts of integers and types. So that means we would still need to like copy this function and then we paste it, and then in our parameters we like give it like instructions. Instead of now I32, it's I64. But what is the most productive way of essentially doing this? So this is now where the concept of generics come in, right? So whereby instead of us putting like a specific type as an argument, instead of us putting like a specific type, which one we want for our values, we just put like we just make it open. So regardless of whatever you want to do, regardless of the type of array that you're having, it will always accommodate it, right? Instead of always repeating with the same parameters. So instead of now putting like I32, we put like a T placeholder, right? So now, when you check it like this, since the compiler does not know what is a okay, let's go through this error that you're finding here. Cannot find type T in this scope, so it's not finding what type T is. You might be missing a type parameter T. So when we put T like this, the compiler does not know what T is. We need to like guide the compiler. So I tell it when it approaches T, it knows it's like a type, right? Any specific type. So to do that, when we come to our function sum of array, we need to put like parameters, which we normally put with those 2 things, and then okay, like that. So far you can find like our function will handle, let me see this error. We're going to handle this error just right now. Let me first explain. So when you check it like this, you see that we have made this function to become generic. So it means whether you have any type here, whether it is I64, I32, any type that you have, it's going to accept it. Because we've put it to be general, we have not bound this function to any sort of type that we want, right? So now we have this. So why is it not working? So when you come here and you check the error which you're finding, binary assignment operation cannot be applied to type T. So cannot use plus equal or type T. Consider restricting type parameter T to standard ops add assign. So what does this mean? Okay, we have put our values to be generic, right? So what if I had like an array which is like example, what if I had like, not even just an array, what if I had like let's say another data structure like a vector, right? Or let's say I have like an array which is just made of strings or characters, right? So will characters, we cannot be able to like apply addition to like all types, right? Because types are many. It's not just integers. You're dealing with a lot of things, right? So that's why the compiler is throwing this error, because it's like, okay, you've made it to be general, but if the compiler finds like an array which has another type, example like a string, how will strings be how will strings be added? So this is where now the concept of traits come in, because traits, it's like you're giving like you're saying, okay, we'll make this function generic, but we need to give some sort of requirements, if I can call it, right? So when we go back to like our error, you see here it's saying consider restricting type parameter t to standard ops add assign. So standard ops add assign, this is like standard is like the Rust standard library. So it's a library that has in-house methods which help you in terms of development. So instead of writing everything from scratch, you're like helped out, right? So this is like the standard library. So in our operations, and by operations OPS, I mean things like plus, minus, multiplication. So these are all in the standard library, right? So it's saying you need to put a requirement that in as much as we've made all these things to be generic, only specific types which can be added are qualified to use this function. So that's why it's bringing an error. So what we're going to do is we can handle this in two ways, right? So let's use the example we're given here, right? So we need to right. So we need to write like a requirement. Okay, sorry. We need to like write a requirement here. So it's still yes, but it needs to like have a specific requirement. Okay. Yeah. So once you see this standard ops add assign, it's like it helps. It's responsible for this. So if you see when you're like, let's say when you're coding and you're using like 5 plus 7, the compiler does not really know what a plus is. This is like an abstraction for you. So because you're like writing to make the language readable for you, right? But for the compiler, it has something which we call like an add trait. So the compiler will like convert this on the back end. Now how the compiler works underground, it's going to convert it into like other things. So it's not like a plus. Okay, that's why when you see add assign here, this means plus name. So when when someone was like built a compiler, these are some of the things we call like tokens. If I can when it now comes how compilers convert like programming language, which is human, to like machine code, which the machine can understand. So these are the things we call tokens, right? So when you see add assign, it just means plus equal. But if we were just adding, it will just be 5 plus 7, right? Okay, so as you can see now, the error for plus equal is like is gone. But now we're facing another error in terms of like now our num, right? So consider borrowing here using an ampersand. So cannot move out of type T, a non-copy slice. Cannot move at if T implemented clone, if T implemented clone, you could clone the value. So what does that mean? This comes back to the 3 main rules which we normally have for ownership, both in Rust and Cairo. First of all, a value can only belong to one owner. So what were the 3? A value can only a value is like valid within the scope. You guys can correct me if I'm wrong, but the 3 rules were a value is only valid within the scope. By scope, we just mean within these brackets, right? So a value is only used within the scope, and then each value can only have one owner. So by that we mean like this value here can only have array 1 as an owner at a time and all. So I've forgotten the 3rd rule. When we continue, I'll remember and tell you guys. So, but those are some of the rules which we have for like ownership in Rust, right? So what we're having here is like, okay, we are trying to, it's like we're trying this samnum, it's like, it cannot move out of this type T here, right? So what we need to do is, this is now something which we now call trait bounds. We need to give extra qualities which will restrict this, right? So what we need to do is we need to also add like the copy trait. So what does copy trait? Copy trait means it's like telling the compiler, if you see I'm using this here, I've just copied it, I've borrowed it, essentially. I'm not the owner of this num. I've just borrowed it and then I will use it. Yes, so we're not moving this num value from its initial owner and then to the other owner. We're just copying it. That's why if it was not there, it was just it was like that's why if it was not there, we were bringing an error. So copy is like a trait. We also check out if we had time, we'll go through some of the traits which are now specific for Cairo, right? So this is the copy trait. So this is one way of writing it. So when it is now like this, if we come back to our, you see even the error we were having here, it is like gone, right? So if we come back to our terminal and then we like go run it, you can see depending on the values we have here, and they're all working, right? So the reason why we're going through traits and generics is because this helps in writing reusable code. Okay, so if you're working with a lot of things, if you're creating programs, you need to make it as productive as possible. So this here, this is now what we call traits. Traits, right? And we have something else we call trait bounds. So these trait bounds are now like they're now like the restrictions which you put. So yes, these sum of arrays are generic, it can be used anywhere, but we're putting like specific rules which needed to be applied so that this function can work. So this is one way of writing it, right? So you can put it here. If you, or you can also put it, if you want to, you can also like, okay, let me just copy this. So this is why you use another keyword we call where. So it's like you're giving it more information about, it's now you're introducing now the trait bounds, right? So if you put it that way, so you can say like where T. So this is just like another way of writing it, based on how you feel like writing it. So if you want to make it, your code be more compressible, you'll just put all the trait bounds you have here, right? But if you want to, if you have a lot of requirements which you need your type to fulfill, you can now use the where here, like you just adding constraints. Yes, so this is what we use in like trait bounds. So this is just a simple, it's just to show you guys the importance of like traits and generics. Yeah, before we continue, since this will be important, I will show you guys where it is now used in the smart contracts. Do we have like any questions, or we can continue? Yeah, so I just wanted to give you guys like a quick overview of how traits and generics work, both in Rust and Cairo. The only difference is now Cairo, in terms of syntax, Cairo has its own way of like writing traits. Example, if let's say I'm writing like a trait in, I have to put this T here, like let's say debug or something, I have to put like a T here in Cairo. Otherwise, that's not really needed in Rust. But all in all, this is how like traits and generics work. So they just help you write reusable code, which you can put as many things as you want. Yes. So I just wanted to quickly go through this before we start on smart contracts. So far, does anyone have any question? Okay, where is my, okay. Okay, yes, thank you so much, Elle. Thank you, country cousin. So for someone who's entirely new, why is it necessary to utilize the data in generic forms or traits? You can use, okay, so I will talk more about this. Okay, so I think we can continue about ownership. So this one mostly is for something we call the referencing. So when we use like this thing, what is it called, like the asterisks? So I think I can be corrected if I'm wrong, but it's like now we are coming into like the concept of lifetimes. in Rust, which is another like really we can spend a lot of time talking about it. So it's like we're now coming into lifetimes. So this one is used when you like dereferencing. So let me think of how I can easily explain the dereferencing as we continue. Okay, JN, yeah. Okay. Okay, so in my analogy, like I had like a construction site analogy for someone who's like completely new. So let's say we're having like a construction site, the same thing as we said. So if a generic is work that anyone can do, and when we translate it and we connect it to our code, is a function that any logic that you're writing can use, right? So that's a generic. But now with traits, you're adding specific requirements which they need specific skills. Example, in a construction site, if you have any work that you're doing, that's like, let's say, carrying stones, doing whatever, that is someone anyone can walk into a construction site and use, which is what we connect to generics. Now, if we need, oh, sorry, I keep on forgetting. Okay. Yes. Sorry, guys. Yeah, so that's what I was saying, right? And I don't know what I've done with like my slides. Something they're lost. Some information is lost here. Okay, no, it's actually not lost. Okay, guys. So when it now comes to traits, these are like when it comes to like the construction site analogy, these are specific jobs which require specific skills. Example, if you want to come in if you want someone to do electrical wiring for your workplace, right, or for the construction site, you cannot just call anyone to come and do like the wiring for your house, right? You need specific skills. So that's where someone with the electrical skills will come in, right? So those are traits. They're like requirements or like specifications which are needed for generics, right? So trait bounds are now those tasks, specific tasks which you need to do. And you have to like show certification that you need them, right? When we connect back to our code, you see the standard ops, add assign, and the copy trait, which we had to implement. Those are like now the trait bounds. It's like you're now binding the specific specifications you need that for your generic to work. Okay, yeah. So also for that, I also wrote like another Rust program, which this is just you guys will see it in like the slides when we finish. It's just to kind of explain the concept which I had for the construction site, where here I have two traits which I now have implemented. These are like the skills someone needs in our construction site, right? So just like the way we have the copy trait. So the copy trait, it is the Rust team, they wrote down the code for how copying and borrowing and all these things will work, right? Is so that you don't have to work to write it. You just need to call the trait, okay? So it's the same thing. So if you're writing traits, it's like you're writing the specific requirements. All these things need to share. It's like you're writing the specific requirements which you want, right? Example, the trait manual and the trait electrical. These are just the skills these workers for our construction site need, right? So if you're coming in as a manual person, you need to carry stones, right? If you're coming in as an electrician, you need to install wiring. Okay, so now these types have been saying, I also implemented it as now workers, so you understand what I mean by types, right? So by types, I just mean Cyndie and Mike. One thing you will notice I have done here, which we have not done before, and you will see this syntax here a lot. The hashtag, derive, copy, clone, that is what we call like attributes, right? So what is an attribute? This thing, it's like you're giving the compiler more instructions. So it's not going to be run as code. It's just you're giving the compiler more instructions. So what do you want these things to do? What do you want? Okay, I'm already like at what will I wish I had the code because I removed it. So you guys cannot see the code, right? Yeah, I'm unable to yeah, I'm unable to. Okay, don't worry, guys. As we continue, I'll try and figure out how to I will share this also at the end of the class, like this piece of code, so you can go through it. Otherwise, I'm so sorry, guys. I totally oversight on my end. I forgot someone cannot see very well. So sorry, guys. Okay, so like I was saying, okay, you can zoom in and see. Okay, nice. Okay, so maybe try zooming in on your end. But if I think Zoom only works when you're using a phone, right? If you're using like a laptop, it's really hectic. Okay, guys, just a sec. Yeah, so like I was saying, I implemented my workers as types just to show you guys. So I have two structs here, right? So I have Cyndie and I have Mike. Structs, they just choose to hold complex data, which works together. Example, what if you're writing, like, let's say, let's go back to code. So with a struct, let's say I'm writing like, I need your details, right? So struct person. I need your details. What details do I need? Let's say I need your age. I need the year you were born. Oh, no, that's age. I need your name in like a string format. I need your location. So this is why we are using a struct. A struct is just like a placeholder. It's a data structure which you can have as much information as you want regarding which is related to whatever you want to, and you are going to use these things together. A struct is different from like an enum. Let me say an enum career. Let's give it like an enum career, right? So with enums, it's like, are you working? I can like write, are you working or are you not? So with an enum, the difference between an enum and a struct is that with an enum, you have to choose one of the fields, right? So with a, like example, with a career, you have to choose between, it's either you're working or you're not working. But with a person, I need all this information which is related. So that's why you see I've put like a struct. So that's another thing. That's the difference between like a struct and an enum. These are what we call data collections. In Rust, there are several types, right? So we have a struct and we have an enum. So when we go back to like our code here, so I have Cyndie and I have Mike, right? So it's just a very simple struct. So okay, nice. Yeah, so it's still the same in Cairo, right? So we need to show, okay, here when I have this thing called impl is like implement. The reason why I have struct here, actually, it's because I need to implement some of the things between this, between my workers, Cyndie and Mike. That's why you've seen I've not put them as variables, because if I wanted to, I could have said, let person 1 equals to Cyndie, let person 2 equals to Mike. But now I want to implement some specific methods for my workers here, right? And how do I implement that? I have to put them as structs, okay? So that's why I put them as structs, by the way, because and not variables. So sorry, I want to show which skills Cyndie and Mike have. So that's why I have the impl here, right? So implement manual. So I'm calling, I've decided Cyndie can do 2 things, right? Cyndie can carry stones and Cyndie can install wiring. She's a powerhouse, right? Now Mike can only do 1 thing because he's a big guy. Mike can only do manual things, right? He cannot install wiring. So how do I differentiate the skills my 2 workers have between Cyndie and Mike? I need to write specific, it's like I need to write specific skills they have, right? I need to implement some specific functions to show what they have, right? So that's why I have the implement here. So I've said implement manual for Cyndie, right? So the first function I want Cyndie to have, because she has both skills, right? I want her to carry stones. So I will now come here to my manual trait, right? So I had already denoted the specific traits, the specific skills we want for everyone, right? That's why I had put the word trait. So these traits, they're public by nature. What do I mean by public? They can be used anywhere. So this one, when you were like writing a trait, you don't need to use the word pub, like because remember when I was talking about ownership, I talked about scope, right? So if it was just another function, once this the first, what are these things called? Bracket. So yes, once the first bracket is over, that function is like removed. When you now go do a deep dive into how compilers work and memory, once we go out of scope, that memory is like deleted. So that's how like Rust is able to use as minimal space as possible to someone's hardware, right? So if I wanted this manual to be like a public so that I can access it wherever I want in my code and outside my code, right? I have to put the pub. So just to tell the compiler, please don't remove this yet. I will be using it somewhere else, right? Otherwise, it's going to be so yeah. So trait is akin. Okay, let me go back to that. So trait is akin to a function in that we can call it to perform a certain task. Yeah, I could call it that way, but yeah, I could say, yeah, it's like, I could say it's like a function, right? That you're calling it to perform like a specific task. Yeah, I could call it like that. It's just that you're just using like another keyword. Instead of now saying like a function, it's now like a trait, more of a constraint. Yeah, so it's like you're giving out it's like you're giving out restraints. That's just like how JN has said. It's like you're giving out requirements which you want to be implemented, if I can say so. Yeah, it's like you're just giving out some requirements which need to be implemented in like a code. Sorry guys, my throat is becoming dry. So yeah, okay, got it. Yeah, so it's more like constraints, the way JN has said. Like it's just you're giving out like, yeah, you're restraining to what specifications you want and requirements, right? Yes. Yeah. Okay guys, let's continue. So like I said, I want Cyndie to have two skills, right? So if my first implementation for the manual trait, I will say I want Cyndie to carry stones, right? Remember, now when you come to the trait here, my function carry stones, I did not put any specific implementation inside my function. It's just a very simple function, right? So and this self, I mean the it's like I'm borrowing the manual, right? So that's why I have like the ampersand in the self, right? So when you see carry stones inside, I will put like the implementation. I want print out Cyndie will carry the stones, right? So if we come to Mike I also is also carrying stones, right? So I will also implement the same trait for Mike. He will also carry stones. Mike will carry the stones, right? Now, when it comes to electrical, I will not implement electrical trait for Mike, right? Because if we have these two traits here, if we don't implement them somewhere, they're sort of like, they're not going to be used. That's why we're saying we're implementing, okay? So for Cyndie, because she's also like an electrician, I will also implement the trait for electrical for her. So she was going to install wiring, but for Mike, he's not going to install, right? Now, I have two generic functions. Sorry, I have two generic functions here. So these generic functions, I connected them to our analogy of construction site in a form of like a job advert. What if we released like a job advert for our construction site? Like I need two types of people. I need people who can do manual labor and I need people who can do complex installations. By complex installations, I mean can do both wiring and can do both wiring and manual, right? So it is just a generic function, just like how we saw in the other things, right? So Yeah. So, and as you can see also for here, I also needed to put like a specific, what is it called, restriction. So I had to put in my manual labor, I only need people who are manual. So I had to put the manual trait as a restriction here. If you guys can see, don't worry, I will copy, when I share these resources, I will copy this code and I will put it in like a friendly way so guys can go through it and play around with it, right? So for manual, I've said as a restriction, right? So if you're coming with manual labor, the only restriction I have is you need to do manual work, right? So, and by manual work means you will carry stones, okay? So if you're coming with complex installations, I need you to do two things. I need you to do manual and electrical. So if you're coming in and you're not doing those two things, you're going to be rejected, right? Yes. So the job but anyone can apply. That's what it's generic, but we need them to have certain skills. Those are traits. And you need to show these skills. Those are trait bounds. So that's how the analogy looks like for a traits and generics, right? Yeah. So because of time, in case you have any other questions with regards to traits and generics, we can ask me in like the Telegram group afterwards. There's like a Starknet Africa Telegram group, and I will happily go through it again, right? Okay. Wait. So with that, let's go to now Cairo versus smart contracts. So what's the difference between Cairo? Let me just remove this. What's the difference between Cairo and smart contracts? Cairo is just the same as Rust, right? So it also needs like a main function. What do I mean by that? Let me just go to my terminal, and then we go to like our example 2. Okay. Just a second, guys. Ooh. Yes. So as you can see, this is how like it's similar to just how like the Rust we were doing, right? It's just the same, okay? So so as you can see, just like how our for a Rust program to run, we need like a main function. It's still the same with like Cairo. Right, so this is a default. They were just in Rust when we made like a default. When we made a new program, it has the default hello world, right? So for Cairo, it has a default Fibonacci. It's called like a Fibonacci sequence. Okay, so if we were to run it. Yeah, so it's still the same. It's just different syntax, right? So as you can see, also for Cairo, if it also needs like a main function to run, right? But when we now come to our smart contracts, as you're going to see, smart contracts, they don't really have a main function. They just have several entry points, and you remember when I was talking about specific instructions which you need to give the compiler, like the derive, copy, clone, right? It also needs such attributes to give the compiler like more information and metadata about the program, right? As we're going to see later on. So that's the whole, when you see like a program in Cairo and you're seeing it has like the hashtag and then the square brackets and then information inside, it's just more information to the compiler. Okay, so that's one thing. So like I said, Cairo, you can use it outside of Starknet. By the way, you can just write like a simple program and it does not need to interact with the Starknet network at all. Like you can say, this is just a simple sequence. I mean, a simple program, right? It does not need to really interact with the Starknet network. Just the way you can like a smart, that it's just normal code, right? So with now smart contracts in Cairo, the goal is to interact specifically with Starknet network, right? So you're designing programs which are going to be interacting with the blockchain. So if you're writing like normal applications, but you need the whole concept of Cairo, if you're writing like normal general purpose apps, but you need them to be sort of provable, you can always use Cairo. But if you're now writing programs designed to run on the blockchain, you're now going to write smart contracts, right? Yes, so that goes to our third point. It can create provable programs out of Starknet, and the Starknet smart contracts are like exclusively for Starknet network. Okay, so one more thing which is important to note: Cairo programs are run by the Cairo virtual machine. So when you see me run like the Scab Cairo run, and you're seeing it's like compiling, finished, running, behind our program now is something we call a virtual machine. A virtual machine, it's just an environment that helps you run and compile your code here and convert it into like machine code that your hardware can understand, right? So that's a virtual machine essentially. So without a virtual machine, our laptop here cannot understand what this is. This is just readable code for us, right? But with now a virtual machine, it compiles it and converts it into machine code that the laptop can understand, right? In Rust, that is called WASM, Web Assembly. In Cairo, it's called CASM, Cairo Assembly, right? Yeah, so that's a virtual machine. So just like how we have it's like Java. I don't know if anyone has interacted with Java, but Java also has like its own virtual machine, right? There's a language for Web 2 called Java, right? So Rust has its own virtual machine, and Cairo now has its own virtual machine. Now, one thing which is notable, which when you do a deep dive into like Starknet, you'll understand that Starknet contracts are run by the sequencer. So Starknet contracts, when you like once you run it, it is the sequencer which is like running it, especially when you like deploy it and all these things, it is run by the sequencer, not the virtual machine. What does that mean? It's because normally with smart contracts, you will be doing things to the blockchain, right? So if I've written a smart contract, which is, let's say, to record some record details. Let's say I want to record how many people are here in this meeting. So I write a smart contract, right? So for everyone who's joining in the meeting, we are updating the network of Starknet. We started with 0, we now have 1, we now have 2, we now have 3. So to do that, we need the sequencer, right? Because remember, I said the sequencer is the one which is responsible for ordering transactions. And in the beginning of the call, I said transactions are not just financial transactions. Like, hey, I sent 2 Bitcoin to 2 Stark tokens to Eve or Bob, or I sent 2 to JN Kamau, right? Yeah, so those are transactions. So anything that you're doing within the to enable interacting with your contract, that's why it's needed to be run by the sequencer, so that any things that you've written that need to write to the blockchain or get information from the blockchain and all, they are taken as transactions which needed to be run by the sequencer. So these are some of the differences between Cairo as a language and now smart contracts. Up to there is like is everything like sorry, is everything like, does anyone have any question? Okay, let me continue. So with that, we come to now simple storage contract. Let's go back to our analogy for okay, this time actually, at least I have the code here, so thank goodness I had put it. Yes, so this is this. And also in case just a minute, just for house rules, in case someone came back a bit later, I had shared in the very beginning of the call some of these things. So this is the first link where on your end, to avoid just listening, just active participation in the group, in the class, this is why this is the smart contract like we're going through, right? So this is the link. So you can click on it and then you go check it, and then we check async as we continue. Okay, yes, so let's continue. Okay, so yeah, so here it is actually when you come here. let me show you guys. Here it is, right? So let's continue to like the slides. Now, when it now comes to smart contracts, there are two very important things which are important in like when writing smart contracts. We have something which we call storage and functions. We're going to go through it. So that's like the blueprint of a smart contract. Your smart contract should not lack storage and now the functions which you want to write, right? So, okay. Trait. Oh, trait is like interface in Java. Yeah, I think I had, yeah. Traits are like interfaces, by the way. The people who have done the object-oriented programming, I don't remember they're called interfaces, right? Yeah, I also, thank you, Temi. I do believe they're also called like that in the OOP, object-oriented programming languages. So let's continue, guys. Like I was saying, in a Starknet smart contract, the two things which are very important. One is storage, and the other one is now the functions. And for functions, which we're going to see later on, we have like public functions, private functions, and all. So, okay, let me take you through this, and then we continue to like as we connect the dots, right? So this is just a simple, okay. No. Cairo and Java are not similar. They're actually really not similar at all. So the one which is similar is Cairo and Rust. So if you want to see, let me just share the Rust book as well. So one thing you can do to help, you know, sometimes it's good to like learn two languages side by side so that it helps with like getting like a general, like a very big overview of how languages differ and work together, right? So if you want to go check it out, you can come here and Justice, right? You can come and check this. Oh, so yes, Henry, she was just trying to, yeah. So Rust and Cairo was actually built on top of Rust. Rust, they just because the first version of Cairo was like built in Python, and then it was so slow. The interface was like really, for developers, the interface was like really not nice. So they decided, that was Cairo 0, right? So they decided to move on to Cairo 1. So Cairo 1 is like they copied, as if I can call it copied, they copied how Rust looks like, and then they added and changed some few things here and there. So when you continue in the like programming journey in blockchain, you'll find some of the protocols, they have sort of emulated how Rust looks like. Example, when you check out this protocol called Aptos and Sui, the language called Move is also like inspired by Rust. Also, when you check like Arbitrum, it's also like, although with Arbitrum you can use Rust, right? Yeah, no, not Arbitrum, Soroban for Stella. There's also another protocol called Stella. Their language is like Soroban, right? So it is also like an interpretation of Rust as well. Yes. So let's continue. Yes, the Arbitrum stylus. Thank you, Moses. Okay, so like I said, we have, first of all, before we even talk about the interface here, I have two things which are like important: storage, and now the functions which you want, right? So before we continue, what can you see here? First of all, like I said, always remember, when you see this, you just know we're giving the compiler more information, right? So we have two things here. We have Starknet interface and we have Starknet contract. Now, remember, when we were writing the Cairo programs, we have the function main, right? So in a Starknet smart contract, we don't have like function main. You have to write this attribute here. You're telling the compiler, this is now not like a Cairo, general Cairo program. This is now a smart contract. Just like how in Solidity, what's that terminology for Solidity for writing, introducing a contract? I've forgotten for Solidity, but it's also almost the same. like you're just telling the compiler, I'm introducing a smart contract, right? So this is the name of our smart contract. As you can see, it is a module, right? So this is our simple storage smart contract. Okay, so like I said, when you're using this, you use core Starknet storage. This is some of the method, some of the function, like some of the functions you're given by, they've written by Starknet to use, right? Just like how we use standard ops, add assign. And now storage pointer read access is for us to enable to read whatever we've put in storage, right? Storage pointer write access is whatever we want to write when we want to write to the storage, right? So this is you use this essentially when you want to like access the storage for Starknet, and not just access it, but you want to read whatever you've written in the storage of the Starknet state. We call it Starknet state. And you also want to write, and you want to change the state for the blockchain essentially, right? That's why we have this use core Starknet storage pointer read access, storage pointer write access. So when you go and read deeply, since we're not going to be able to read because of time, when you go read deeply about storage in smart contracts, you're going to find these things called pointers, right? So it's written in like the Cairo book. After the session, I'm going to like give guys where the specific links are. So you go see essentially how is data stored in Starknet, right? And how do you even reach the data, right? So also when you learn Cairo and you also run Rust, you're going to do some advanced things called pointers and all, right? Yeah, so, okay. So like I said, we need storage, right? So with storage, we have this attribute here. You need to tell the compiler, I want to like store something on I want to store something to Starknet, right? That's why you need to put the attribute storage, right? And like I said, with storage, so here this is like a default, right? So we just want to store some data here in the network, right? So that's why we have the storage attribute. Now we also have this is like when you want to like write like public. We will also see when we go to functions, there's something we call storage functions. We have two types of functions. We have public functions. These are functions which you need. They will be like available. So if anyone is interacting with your smart contract, they can access these functions, right? And interact with them. You also have like the private functions. Private functions are functions which are restrained inside your contract. So they're just private. No one can access it outside of the contract, right? Yes. So like I said, yeah, and these are implementations. Now, these are the functions which you're writing for your simple storage contract, right? Okay. Contract state. Contract state is just the state of your contract. This is like a keyword which is given by a Starknet when you're writing like smart contracts. So this is just the state of the contract you're in, right? Okay, with that, let's go back to the interface, which I was talking about. So the interface, this is like a blueprint. This is like your advertising. What does your contract have, right? So once you're done writing your smart contract, you now come and you show what does your smart contract entail, right? It's like you're now advertising, what does my smart contract entail? So that's why you see it has the attribute Starknet interface. So you're just telling, so that you're just telling the compiler to be able to like, what's it called, to differentiate. So the code in here, it's just implementation. What have you implemented from here, right? As you can see, this simple storage, the only thing it does, it stores like a number in the blockchain, right? So this is the set, and the get is just to read. So this one is just for storing data, and then this one is for reading the data. Okay, so with that, and as you can see, we've implemented it as a trait, by the way, here, right? That's why I was very I wanted it to like that's why I wanted us to go through traits and generics first. Okay, so yeah, this is with the Starknet interface, it's just you just showing the blueprint of your smart contract. What functions do they have and all? Okay, so this is just a very simple storage smart contract. Okay, so one thing I want you guys to see here, which we might not have talked about, is this ref and this at here. And as like, remember I said the differences in the syntax now between Rust and Cairo come here, okay? Because as you can see in like our trait here, I simple storage, which is just explaining more about our smart contract. You can see we've put an I here, right? So it's like a requirement. One of the you just put it in like here so that someone can identify and say, okay, this is like an interface. It's just explaining more about the interface, right? Now, here we had our types. You remember when we're now talking about generics, right? So we have our type, which is contract state. And this is like a keyword, which is provided for by Starknet when they were designing smart contracts to say this trait here will always be about the state of your contract. Okay, that's why you will see it will be super, you'll be using it like a lot, the T contract state, right? Yes. So before we even come here, let's go and check out here, right? So we have two functions. The set, it's like we're just adding data to the blockchain, right? Okay, so self.storedata.write. So remember when I was talking about the write storage pointer write access, this one, when you import it here, it helps you now use this function .write, because as you can see, we have not written any write function, right? That's why we have it here. Otherwise, if we could have example, if we could have commented, if you could commented it out, you can see it does not know what this is, right? So these are some of the implementations which you use to avoid, they just make your work easier, because you would have had to now write like the behind the code for now, right? Because it's also like a code written, right? You could have now had to write out the logic for writing to blockchain, and that's like a lot of work. Okay, so that's why you see we have imported storage pointer read access, storage pointer write access. Okay, yes, and those are traits, as you can see. So normally in development, what we normally do is when you see something, you normally just go and then you like read behind the scenes of how they work, so that when you're seeing it being used, you understand why it's being used there, right? Okay, that's just something I was taught to do. So when you're seeing something, helps understand. Also, with the same with development in Starknet, right? It would also help to really understand the architecture of Starknet. You can also do a deep dive and you understand even how does the compiler work. When we say provable programs, because technically speaking, we say how is this proof generated? It's because the compiler generates something we call an execution trace, right? But that's something you can always go and read behind, just understand behind the scenes of everything works. So when you hear something being used, you understand why is it being used. Okay, yes, so let's continue. Like I was saying, this function here, it's for writing, because we're just writing one variable, like one variable to like a state of like to the blockchain, right? So this is just for writing one value, because you can see it's just one value, right? Which we put in storage, the stored data here. Okay, so if you want to store something in the blockchain, you need to put it under storage. Otherwise, it will be like null and void when you don't put it under storage. So everything you want to like store and use, all the data you want to store and use within your blockchain, you have to put it under the storage attribute. Okay. Yes. So let's continue. Function get. This is just for reading only. Okay. Yeah, it's just to read. That's why you see the read method here. Okay. Now, let me go back to something else before we continue. You can see something else which is super important. It's just that we didn't have time to go through it. When you see our function set here, I have this ref here. Okay, I have this ref, right? But in here for reading my data, I have this at here. So what do these two do? Okay, so The difference now between Rust and Cairo is when we're borrowing something, when we go back to like our code here, where was our code? You could see me borrow because I was talking about ownership, right? You could see me borrow this num value, okay? So now how do you borrow in Cairo? In Cairo, you borrow two ways. First of all, when you're using the ref value, it's like you're borrowing this contrast and you're borrowing the variable x, right? But now you want to make it mutable. I'm not just borrowing it to use it, I want to make it mutable. So if you're writing anything which will change the state of the blockchain, you need to use this ref. So this one you will see it when we go back to Cairo book and you go through like the entire programming language, right? And you go to ownership in Cairo, right? And you also see how traits and generics are also implemented in Cairo, okay? So back to it. So when I have this ref, like reference, when I have this ref here for, I want to borrow these two things. I want to borrow the contract state which we have, and I want to borrow, like, I'm just borrowing this contract state, right? So when I'm borrowing it, I want to change the state of my contract, okay? That's why I need this ref here. Now, that is when we are storing the data, right? Now, when we want to just read what we stored, this stored data, when we just want to read it, I don't need to use the ref because I'm not changing any value. So I'm going to use this at here because I'm not changing anything. And that, when you check in the Cairo book, is called snapshots. So it's like I'm just checking at a certain point in time, what was the state of my contract, right? I'm not writing anything to it. So these are some of the small nuances which you also need to understand when you're like writing smart contracts. So that's why you see here we have ref, and that's why we see here we have the at. So the at, it means you're still borrowing the state of the contract which we have, but you're not changing anything to it. So you're just taking a snapshot of it, okay? But if you want to change the state of the contract and you need it to be mutable, you need to change some of the 1, 2, 3 things here, and there, you now use the ref keyword. Yeah. So this is just a very simple implementation of Starknet smart contract, okay? So this is also similar to, let me just go back to example. What if I wanted to like make like to bootstrap, like I want to start writing smart contracts in Cairo, okay? So what do I do? So this you will also see it in next week. Next week it will be implemented at a very it will be implemented deeply, but now there's some specific toolings which you need, and some of which we have I've set up already in my machine is something which called a Starknet Foundry, okay? So it's just like how Foundry, for someone who's coming from like an Ethereum development bit, we have some tooling called Foundry, right? So Starknet Foundry, okay? So let me just make another directory, and then I want to like write my first smart contract, and okay. So the first thing you can do, like we started with scab, right? And notice something, if you guys remember, like when I was doing this, first of all, you saw which test runner do you want to set up, Starknet Foundry and Cairo test, right? So what if I want to use Starknet Foundry? Let's see what you're going to get. Okay. So there's a difference between the setup and my environment between the Cairo program, which we had, and the tests, right? So to help us, I'll need to, let me look for, okay. So to help us out, I want you guys to see like specifically some of the small things, right? So here I have my setup for which is now for Foundry, right? I've set up like an environment which will use Starknet Foundry, of which when you continue now writing smart contracts, you need to deploy them. And things like Starknet Foundry, they help a lot. And also, there's also another tool called Starkly, but mostly we use Starknet Foundry. So they help in interacting with your smart contract and deploying it to whether it is the developer net, which we call DevNet. We also have testnet. By the way, we have 3 types of networks in Starknet, right? We have DevNet, we have testnet also, and we also have like the mainnet. Okay, so this we have the source, and then we have tests. So when you implementing like a smart contract with a Foundry, you see we have it's set up for you 2 things. We have like lib.cairo, the source file here, and then we also have tests. So it also helps, it gives you like a template for writing tests specific to your smart contract, right? Because as we continue with the bootcamp, you also learn something about testing, because testing is also very important, ensuring your logic works, everything is working before you deploy, right? Yes, so when we come to now the initial Cairo, you see it only has the source file, right? And now this target comes when we compile. You remember when we ran the command scab Cairo run program, right? So and it compiled it to what? To Sierra. So just a second. The way that's why I was saying it's important to do like to understand the architecture of network of Starknet, because when you like compile a Starknet or a Cairo program, it does not directly compile to the machine code I was talking about, like the CASM, right? So it has this safe intermediate representation here. It's called Sierra. So it's not the same as Rust. Rust, it will compile to WASM, right? So with this one, it will have to first undergo Sierra, and then now this Sierra is now the one which is used to convert to the assembly code, right? Yeah, so this is some of the things. So when you see like a Sierra.json, it's just its full name is Safe Intermediate Representation, if I'm not wrong. Yeah, so you need to when you're working with a Starknet, you find your code has first a safe interpretation, a Sierra, and then Sierra is like the middleware, and then afterwards is now CASM. Okay, so these are some of the things, notable differences which you can see. First of all, even the default is specific for like a Cairo program. But now when you want to use a SendForge, as you can see, it has now a default hello. It's like a hello world for Starknet smart contract. Okay, so it's also it's just function, it's just increasing like a balance and get back. It's almost similar to the storage smart contract which we have. Okay, so it's just that it's called like a hello Starknet. And like I said, remember this trait for T contract state, sorry, for trait, it's something which you'll be interacting with a lot. Okay, and also like I said, you can see also here when you see a ref, you know this thing will be writing to our state of the contract, right? But if you see an art, we're just taking a snapshot. So this is what I wanted you guys to see. And the test, right? So this is one way. This is one way of when you're using Scab. You can, as you will see also next week, you're going to use something we call a SendForge. So just before we continue, oh, fast. Oh yeah, okay. So you're going to use something we call a SendForge. So you can, when you want to like set up your environment for smart contracts, you can use Scab, by the way, and then you have to make a lot of adjustments also to like the TOML file. This is like a file which has like configurations, the configuration file, right? Or you can directly, once you set up Starknet Foundry, which you learn how to set up Starknet Foundry and all these other tooling next week, you just initialize with like, let's say I want to initialize this second, right? Yes, so these are some of the small things. So as you can see, Okay. Yeah, so it's still the same thing. It's just I wanted you guys to see like it's coming with like a configuration file, which as I said, we're going to learn deeply about it next week. Okay, so it comes with two configuration files, which you're configuring what you're building, right? Of which I forgot to say, when we come to like configuration for a Starknet smart contract, you need to write this so that you give more details, that it's like you're telling, as I said, you're giving more information that I'm writing like a Starknet, a smart contract. So I've seen it and then I've remembered I forgot to like mention. So this is like this is just a configuration file where it's mostly in Rust and in a Cairo, right? Where you write whether it is any dependencies you need, if there are extra libraries which you need to import, you're going to put them here, and all these other things. Yes. So yeah, away from now Starknet Foundry. So this is the simple smart contract, right? So when we come back to our storage, it's the same as what I was saying, right? So when we come back and we talk about it in like an analogy form so that you can connect both. The Starknet interface, it's like when an architect writes like a blueprint of your house, they're going to show you, oh, your house is going to have this and this and this and this. So that's the Starknet interface, right? Now for storage, okay, sorry, keep on forgetting. For storage, this is the furniture which you will store in your house, right? So that's the same with storage, the data you're going to store on the blockchain, okay? So the ABI embed version 0, it's just like now it's like you're giving now information. This is where our function is going to like start. You're also going to see another attribute called external. It's not just this ABI, there's also another attribute called external. It's like you're now writing the functions which you're going to be implementing in your smart contracts, right? So it's just the process of building the house which you are building, okay? Yes, so the interface, the blueprint of your house, storage, the furniture which you're storing in the house, implementation, this is how the actual process of building the smart contract, right? Yeah, so this is still the same as what we have explained. So we'll share in like the slides, right? Yeah. Whew, okay, just a second. So remember we were talking about storage, the way we were talking about it, right? So with contracts they have like, because where are the so if I have a contract, where do I store the whatever I want to store, and where's the contract also stored, right? So they have like a space, like in the blockchain they're given like a dedicated space where data can be stored on the blockchain, okay? So that's more on like contract storage. And it's like a map. It has when you go and check out deep in details how exactly does this storage work, it's like a big map, and they have a lot of slots essentially. So, and each slot is holding the default type which we're talking about in Cairo, the felt 252, the field element 252, and they're initially set to 0, right? So when you're declaring the storage variables, like I said, you need to declare and you say and you have specifically to write storage. You can't like write the attribute storage. Example, you cannot write the attribute storage here and then let's say I want to like say store. You know, it does not work that way. It is given like you have to write specifically storage so that the compiler knows that this is a specific struct and it's all about storing data on the blockchain, okay? Yes, so that's why you have to put storage. It's just like how when you're going to see when we get to like contract events, this has something special which we call events, okay? Yeah, so you can store simple types which we stored here, and you can also store complex data, which we're not able to go through everything, but when you store complex data, you have this trait we call it store, and you need to call it. Yeah, so I'll quickly show you guys before we finish because we're almost finishing the call. Okay, so like I said, you need to read when you want to retrieve the data, and then when you want to write it, you say write, right? And if you have some custom structs which you embed, you nest them inside the storage struct, and they're very complex, right? You need to use this attribute here, the derive Starknet store attribute. You need to use it to implement it, okay? Yes. So this is an advanced concept which, because of the interest of time, we might not be able to go through it now, but there's something which we also call the storage node. So like how I said, we have the simple data, right? So if you have this some complex data which you need to nest inside, like let's say I'm nesting like structs inside of my struct, or enums or whatever. If you have just complex data structures which you need to store in your blockchain, you need to use this attribute here, Starknet storage node. So it's like you're giving out the metadata that this is not just simple data I'm storing on the blockchain, it's complex data, okay? Yes. So yeah. So okay. Let me quickly also take you guys through events and functions before I come to the storage addresses, okay? So the functions which we're having is like just like how we have the function set, the function get, the primary way of interacting with the smart contract, because normally with development in smart contracts, it's either you're accessing data or you're writing data. Normally you read, write. So that's how smart contracts are. You either read from the blockchain or you're writing to the blockchain, okay? Yeah. Like I explained, remember we have the ref self allows reading and modifying the state, okay? So remember when I said when you use the at, it's like you're just reading only to the state, okay? So constructors, it's a special function. We don't have it in like the simple storage contract we have, okay? But it's a special function which once the contract is deployed, it runs, and it's like initializes the state of the contract. It's like saying, okay, the contract is deployed, okay? So our contract state is 0, right? So if we deployed this, although we have not written it here, if we had written like a constructor, if we deployed it, our simple smart contract into like Starknet, so once it's deployed, it's like initializing our state of the contract, okay? Yeah. So this is something like I was saying, the public functions, they need to be accessible from outside your smart contract, because this smart contract, you're writing it to interact with other things in the blockchain, okay? So you use the ref, like I said, to read and modify the contract state, okay? And also, like I was saying, this attribute ABI embed version 0 and external version 0, you annotate them to just show like these are public functions which I'm writing with, okay? Yes. So as you can see here, the difference between private functions and public functions is they don't have yeah, so the difference is that between this, okay, let me just see. Okay, someone, okay, yes.
Yes, sorry for interrupting. So I wanted to like bring to your notice the time we should be rounding
Okay.
up. Yeah.
Okay, yeah. Okay, guys. So yeah, so the difference between just the private and the public functions is the public functions don't have these attributes which we wrote, the ABI and the external. yeah, sorry guys, I did not even see time has gone really fast actually. Sorry guys. Okay, so yeah, so we might not be able to handle everything, but there's something really important also I wanted to like share, which is Syscalls. Again, if we will share these slides, okay? And if you have anything which you have any questions, you can always hit me up later and then we will go through them, okay? But something really important I wanted to talk about is Syscalls in Starknet, okay? So what are Syscalls? So remember, when you're writing your smart contract, you might not be able to directly access the storage of your blockchain. Okay, so I wrote it as an analogy of like a phone. When you like buy a new phone, you have some applications which come as default. Okay, just a second, I'm just okay. Yeah, when you have when you like buying a phone, you have default applications. Okay, so you have like system apps which come with the phone. Example, like let's say I want to change like the system brightness of my phone and camera. This came with the phone. Okay, so if you install WhatsApp is an external application, right? So it cannot directly access the camera. On the back end of how it is written, it needs to like request. So that's why we call it like in technology, we call it like an API call, right? So it needs to request, I want to use the camera. Please, phone, give me access to use the camera, okay? So once it's requested that way, it will be given access to the camera, right? Similarly, when you write a smart contract, you don't just directly access the blockchain, okay? You need to request. So how do you request something from a blockchain now? Well, how do I request from Starknet? We use what we call now Syscalls. Just how WhatsApp will request from to use the camera, you need to now request to maybe get some information from blockchain. You use now Syscalls, okay? So what are some of the Syscalls which are used, which you'll be seeing them quite oftenly in Starknet? So these are two snippets. On my end here, it's like the default implementation. I got this. The reason why I got this is because when I was like an intern in Nethermind, we were maintaining the Starknet sequencer. So one of the major duties we had to do was write the Syscalls which people are using so people can access the Starknet, okay? So this is just like a snippet of some of the Syscalls, and these are the Syscalls you will be using, okay? If you need to call a contract, you use this function. If you need to deploy, you need to call to use the deploy Syscall. These are some of the things you'll be using, okay? If you need to get the block hash of the current, or let's say a specific block, use this Syscall. If you need, so these are some of the so here I've put like a link to, you can go check out in Starknet Cairo, all the Syscalls which are implemented, so that when you're continuing to become more advanced, you can always know how to use them, okay? Yes, so yeah, so I really wanted to talk about, because just to give clarification that in as much as you're writing a smart contract, you also need to request to know what is the state of the blockchain, because the state we were talking about is the state of the contract, okay, not the state of the blockchain. Yeah, so this is as an assignment, this is like you just write like a simple contract which tracks user balances for a reward system, and they need to have functions which add points and redeem points. Yeah, so so sorry guys, because of the interest of time, we're not able to go through everything. So in case you have any questions, because I wanted when now offline, you can always hit me up and then we can go through events and public and private. Okay, public and private. So events, you're just updating. So events are just updating the world. By the world we mean the blockchain, right? So example, you're just telling you're just updating the state of the blockchain, okay? So in case something happens and you need to update something which was in your smart contract to the blockchain, you use like events. Yeah. Okay, guys. Okay, yeah. So if anyone has any question, again, I'm so sorry, I didn't know how time flies really fast, okay? So we had to rush through with the event, so I was not able to show you the other smart contract which we had written, but yeah, you can always hit me up after we'll talk about. Okay, so the assignment again, so we'll still share it outside of here. So yeah, so this is just the assignment, we'll still share it after the call. All these resources, I'll share them in the Telegram group for Starknet Africa. So in case you have not joined the Starknet Africa Telegram group, you can join. Yeah, but all these resources, I'll share them there. Yes, Okay, after 2 hours, thank you guys.
Thank you so much, Cyndie, for that beautiful, insightful session. It was so amazing. Thank you so much. Guys, just like she said, if you have questions, feel free to drop all your questions on the Starknet Africa group, and you can also like reach out to her in DM. She will be like glad to have you. And also, please, the assignment forms will be shared tomorrow, and the feedback form as well. And don't forget, if you have not been following with your assignment, the forms are open for you. So make sure you follow up, because that's how we can track that you're actually like actively participating in the boot camp, and that's how you'll be able to like get your spoke at the end of the boot camp. So yeah, I think that will be all for today. So resources, assignments and all will be shared after the class. So if you have any question, you can like ask now before we close the call. I think, yeah, that's all. Okay, yeah, I think that's all. So, thank you guys for joining, and have a restful. I okay, okay, okay. All right. Bye, guys. Bye. Bye, everyone.